Question 12. The probability that Rebecca will win any game of snooker is P. She plays 2 games of snooker. Now part A says complete in terms of P the probability tree diagram. Okay, so this is her first game. She can either win or lose. Now if she wins, her second game she could either win or lose. If in her first game she loses, she could either win or lose. Okay, now in her first game, whether she wins or loses, okay, those have to add up to 1 because she can either only win or lose. Either of those has to happen, so they must add up to a total of 1. Now if these were numbers, okay, you would do this number here, take that away from 1 to leave you with the probability of the losing. Okay, as you haven't got any numbers this time, this is just going to be 1 take away P. And the second game here, if she wins is P, so the lose must also be 1 take away P. And in the first game, if she loses, the probability of her winning is still P, and the probability of her losing in her second game is 1 take away P. So let's have a look at the mark scheme and see how you get those 2 marks. So those 2 marks, you get the first mark for seeing 1 take away P on any of the branches. Okay, so as long as you put that in at least one of the branches, you get the first mark. The second mark simply comes from filling in the whole probability tree diagram correctly. Okay, so let's move on. So part B says write down an expression in terms of P for the probability that Rebecca will win both games. Okay, so very easy. If these were numbers, the probability that she would win both games, you would times the probability that she wins in the first game by the probability that she wins the second game. Okay, now, as we don't have any numbers, okay, all we know is this is P. It's the same thing really. Okay, so all you have to do is it's going to be P times P to get the probability of a win-win. Okay. Now you could also do P squared, that's absolutely fine as well, or you can have PP. Okay, any of those will be absolutely fine, and that's worth 1 mark for part B. Part C, a little bit more tricky. It says write down an expression in terms of P for the probability that Rebecca will win exactly 1 of her games. So exactly 1 of her games. So let's have a look at this tree diagram and let's get a different colour. So if these were numbers, you would multiply across the tree to get the probabilities, okay, and then add up the probabilities that you want. Okay, so the probability that she wins exactly 1 of her game. So win, I don't want that. I do want win, lose, so I want this probability here. Do want lose win because that's also exactly winning 1 of her games, and I don't want lose lose. Okay, so the probability of win lose, first of all, let's have a look, let's write that down. So the probability of win lose is P times by 1 minus P. Okay, so that's P times by 1 minus P. Now don't forget those brackets. Okay, I also want lose win, so that's also P times by 1 minus P. Lose and win. Doesn't really matter which way you time something, so I'm going to write that the same way. Okay. Now if those were numbers, we've worked out those probabilities now, and then we need to add those probabilities up. Okay, so that's no different from what we're doing here. So the probability of Rebecca will win exactly one of the games is those two probabilities added together. So let's have a look. So it's going to be P 1 minus P add P open bracket 1 minus P. Now that is the expression, okay? Now of course you can multiply these brackets out and then cancel it down, but you don't need to. All it says to get the marks is write down an expression in terms of P for the probability that Rebecca will win exactly one of the games, and we've done that, okay? So this is a 2-mark question for part C, and let's have a look exactly how you get those marks. So the first one's a method mark, okay, for seeing at least one of these P times open bracket 1 minus P close bracket, okay, and the second one comes from the final answer, basically, of adding those two together, okay, to give you the actual probability that Rebecca will win exactly one of her games. And that's it.